Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear students, I hope you are doing well. Our today's topic, real number, which is chapter number 1. Now I want to discuss about real number. What is real number? Any number that could be plotted on a number line is called real number. There are two types of real number here: rational number and irrational number. First one is rational number. What is rational number? The number which are written in the form p by q, where p, q are integer and q not equals to 0, then it is called rational number. Now some example. Number 1, any kind of integer, suppose 1, 2, 3, minus 1, minus 2, minus 3, these are rational number. Number 2, after square root or cubic root, if we get integer, then it will be rational number. Suppose root over 4 equals to 2, root over 9 equals to 3, cubic root 8 equals to 2, cubic root 27 equals to 3. These are always rational number. Number 3. Any kind of terminating decimal fraction, it will be always rational number. Suppose here 1.25, 3.256, that means any kind of finite number. Always rational number. Point number 4. Any kind of recurring number, always rational number. So we can write here, suppose 0.35 recurring, it's a one kind of rational number. Now irrational number. What is irrational number? The number which cannot be written in the form p by q, where p, q are integer and q not equal 0, then it is called irrational number. Now some example here. Any kind of infinite number, always irrational number. Infinite number. Number 2, square root or cubic root of prime number is always irrational number. Suppose here square root 5, square root 2, square root 7, these are always irrational number. Now prime number. Now prime number. which is prime number except 1, every natural number that can be only divisible by 1 or the number itself is called prime number. Suppose 2, 3, 5, 7, etc. These are always prime number. Here 2 is divisible by 1 and itself. That's why 2, 3, 5, 7, these are prime number. And here 2, only one integer which is even prime number, and others are odd prime number. Now we can solve some mathematical problem. Our first mathematical problem is question number 10. 1. Find two irrational number between 0.31 and 0.12. And question number 2. Find a rational and an irrational number between 1 by root over 2 and root over 2. So first one is here. Firstly, we can write, let one number is a equals to 0.2001, 0001, and so on. And another number will be is b equals to, here we can write 0.2101, 0001, and so on. Here let two number, and now we can write here clearly a and b are two real number. A and b are two real number. And both are greater than 0.12, and less than 0.31. So now that is, it will be 0.21 less than here 0.2001, 0001, and so on, less than 0.31. And another number is 0.21 less than here 0.2101, 0001, and so on, and less than 0.31. Here again we can write here, after this line we can write here again, here these two number a and b cannot be expressed into fraction. So we can write here A and B are the two desired irrational number. Irrational number. This is the solution of question number 1. And now another one is here. Now question number 2. We can write here find a rational and an irrational number between 1 by root over 2 and root over 2. Here root over 2 equals to, by using calculator we can write here 1.4142 and so on. And another number is 1 by root over 2. It will be 0.7071067 and so on. And now let one number is a equals to 1.01 is finite number, and another number is b equals to 1.101 001 0001 and so on, which is infinite number. So here a is 1.01 and b is 1.10 100 1001 and so on. Here this is finite number and this is infinite number. So here we can write clearly A and B. Clearly A and B are two real number. And both are greater than 1 by root over 2 and less than root over 2. So we can write here, that means we can write here 1 by root over 2 less than 1.01 equals to 101 by 100 less than root over 2, and another one will be 1 by root over 2 less than, here this part we can write here 1.101.001.0001 less than root over 2, less than root over 2. So here this part fractional part, so we can write here, a can be expressed into fraction. So a can be expressed into fraction, so we can say that a is a rational number. A is a rational number. A is a rational number again, but here b cannot be expressed into fraction. So we can write here b is an irrational number. B is an irrational number. So we can write here A and B are two digit number which A is rational number and B is A and B are two digit number which A is rational number and B is an irrational number. Which is the solution of question number 2. Now question number 11. Here prove that square of an odd integer is an odd integer. So we can write here, let 2x minus 1 is an odd integer, where x is an integer, Now we can write the square the square of 2x minus 1. Here it will be 2x minus 1 whole square. Now we can apply the formula of a minus b whole square. So it will be 2x whole square minus 2 into twice x into 1 and plus 1 square. So after this line we can write here 4x square minus 4x plus 1. Now we can take common these two part, this part and this part. We can take common 4x. So it will be 4x into here x minus 1, here plus 1. Now we can write from this part 2 into twice x into x minus 1 plus 1 plus 1. So after this line we can write here x is an integer, x is an integer. So this part 2 into twice x into x minus 1, 2 into twice x into x minus 1 is an even integer. Even integer. If 2 into 2x into x minus 1 is even integer, then 2 into 2x into x minus 1 plus 1 must be odd integer. So we can write here 2 into twice x minus 1 plus 1 is an odd integer. Odd integer. Therefore here square of an odd integer, therefore square of an odd integer is an odd integer. Odd integer proved. This is the required solution of question number 11. Now question number 12. Convert the following into repeating decimals fractions. Question number 2 7 by 11 and question number 4 3 whole 8 by 15. So our first question is here. Question number 2, given simple fraction equals to simple fraction equals to 7 by 11. So here 11, my dear students, look at this. 7 is not divisible by 11, so we can take a point here, and for this point we can write 0. And now 70 is divisible by 11, so we can take here 6, and 6 into 11 it will be 66. After subtraction it will be 4, but 4 is not divisible by 11, so we can take here 0. And now 40 is divisible by 11, so we can take here 3. 3 into 11, it will be 33. After subtraction, it will be 7, and 7 is not divisible by 11, so we can take 0 here. Now 70 is divisible by 11. 70 is divisible by 11, so we can take here 6, and 6 into 11, after multiplication, it will be 66. And now here after subtraction, it will be 4, but 4 is not divisible by 11, so we can take 0. Now 40 is divisible by 11, so we can take here another 3, and 3 into 11, it will be 33. After subtraction, it will be 7. My dear student, look at this, 0.6363. 6 and 3 repeat again, so we can write here our required repeating decimal fractions. So we can write here required repeating decimal fractions equals to here 0.6363 and so on, and equals to, we can write here 0.6 recurring and 3 recurring, which is the required solution of question number 2. And now another question is 4. Question number 4. So we can write here, our question will be 3 whole 8 by 15. After calculation, 3 into 15 plus 8, it will be 53. So we can write here 53 by 15. 53 by 15. So here 15, 53. Look at this, 53 is divisible by 15, so we can take here 3 into 15, it will be 45. After subtraction, it will be 8, but 8 is not divisible by 15, so we can take a point here. Now for this point, we can write here 0. Now 80 is divisible by 15. 80 is divisible by 15, so we can write here 5. We can take 5 into 15, it will be 75. After subtraction, it will be 5, and 5 is not divisible by 15, so we can take here 0. And now 50 is divisible by 15, so we can take here 3. So here it will be 45, and after subtraction, it will be 5, and 5 is not divisible by 15, so we can take 0. And now again we can take 3. 3 into 15, it will be 45. So after subtraction, it will be 5. So we can take 0, and we can take here another 3, and 3 into 15, it will be 45. So after subtraction, it will be 5. And here 3 into 5, 333. 3 is repeating digit, so we can write here we require repeating decimal fractions equals to it will be 3.5333 and so on, equals to it will be 3.53 recurring, which is the required solution of question number 4.